My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 430. In this lecture, we will try to understand KAGGLE computation versus real world. Ensembles are extensively used in competitive settings like KAGGLE. Any competition, basically any machine learning competition. We will try to understand that how KAGGLE or any other competition is different from the real world. KAGGLE is super useful to learn machine learning. So first thing, any competition on KAGGLE or anything cares typically about one metric. They typically care about one metric or one KPI. What is KPI? Key performance indicator. The metric could be, this metric could be log loss, AUC or F1 score, depending on the problem, of course. They typically care about only one metric, and they try to optimize, they will try to optimize this one metric because look at it, it is competition, isn't it? It is a competition where they need to decide who is the first prize, who is the first prize and first prize winner, and oftentimes you will see that, and who is the first prize winner, who is the second prize winner, and oftentimes you will see that the difference between first prize winner and second prize winner is less than 0.1% difference in one of these matrices, isn't it? At the end of the day, they have to decide. They need to be very objective. They can't be subjective. They need to be they need to be numerical. They need to able to say this team or this person got first position, this team or this person got second position, and to be able to do it, to be able to do that, they need to have one metric which they declare, declare as the most important metric, and all the competitors try to reduce it. If you go to KAGGLE website and look at the scores on the leaderboard where all the scores are scored, you will see the difference between first person and second person is extremely small, and the small difference may not matter in real world. That is the fun part here. We will come to that in a while. One metric may not be the right thing, may not be the right thing in the real world, isn't it? In the real world, when you build a solution, you might want to look at multiple matrices, isn't it, and not just one metric. Of course, you could have even metrics like this. You could have primary metric, you could have secondary metric, and oftentimes it's very hard to define one metric, one machine learning metric like log loss or AUC to be your sole goal. In real world, we often try to look at multiple metrics, isn't it? In some matrices, this one, in some matrices, this is one aspect. Second aspect is, if you are building system for Amazon, if you are building a system for Amazon, your job might be to improve sales or to increase sales. This is business goal, isn't it? The challenge here, what is this? The challenge here is how to take this goal of improving sales and convert into machine learning metric, because machine learning algorithms can't simply improve sales. You have to say reduce reduce log loss or improve AUC, improve F1 score, improve R squared value. You have to say what metric, what numerical, what machine learning metric you want to improve, because machine learning algorithms does not understand what sales means. This is something that lots of machine learning engineers in real world do. They take business metric or business goal, isn't it? Business, what say that this is something that lots of machine learning engineers in real world do. They take business metric or business goal, they translate it to one or more machine learning matrices, isn't it? Yes, this is very important. Business goal, converting business goal into machine learning metric. This task that something don't do in Kaggle computation. This we cannot do. Converting business goal into machine learning model, machine learning metric, not model, machine learning metric cannot in Kaggle. This task that something don't do in Kaggle computation. In Kaggle computation, they give you metrics. They say log loss, reduce it. They reduce it. People who design the computation have done this mapping for you, isn't it? But in real world, you have to do it. We will see in some of our case studies on how to go. In our case studies, even though we are taking data sets from Kaggle, we will focus on how to go on a business problem into real world problem. This is the first difference between Kaggle and real world. The second important key aspect, this is also very important aspect. In Kaggle, I have seen lot of people build very complex ensembles. What is their objective? Their objective is to improve, isn't it? Their objective is to improve the one metric that they care about. Maybe very complex ensemble is ensemble is impractical. Maybe impractical in the real world because of so many things. Because you might have low latency requirement. You have trained 2000 models here in an ensemble. You will not be able to run all of them. Imagine training time required. In the real world, you might want interpretability, especially in medical domain. Kaggle does not care about interpretability, training time, and low latency requirements. So it could happen. Some of the solutions you see on Kaggle could be impractical, because in the real world, as practitioner, somebody who is solving business problem or real world problem, you have many other constraints like low latency requirements, training time, and interpretability, which are not given important in Kaggle computation. So this is another key aspect of difference between real world and Kaggle. But remember, Kaggle is a great for computations. The way Kaggle operates is a brilliant way for computations. I actually loved and suggested a lot of people that there are a lot of things that we can learn from Kaggle computations, because Kaggle boils down the whole idea into single metric that people can compete on. For competitive settings, Kaggle is my favorite as usual. But when compared to the real world, there are some of course I'm not blaming Kaggle for this. It's extremely hard to be able to as close as possible to real world. Kaggle has done a terrific job, but lot of things that you can learn from Kaggle which are useful in real world. You can learn lot of things like data cleaning. You can learn things like data cleaning, isn't it? Data cleaning, data pre-processing, I can say feature engineering, isn't it? I will repeat. You can learn lot of things like data cleaning, data pre-processing, lot of feature engineering ideas that you can learn from Kaggle by participating in Kaggle computation and read winner solutions. This is important. Winner solutions. Winner solutions. Use Kaggle as a great place to learn, especially aspects like data pre-processing, data cleaning, and feature engineering. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.